Alright, let's look at something like suppose it's more of a word problem. We're find the closest point on f of x equals x squared plus 1 to the point 2, 2, something like that. Then I could use the distance formula, and here we're going to find an x and a y, and so we're going to want to take x minus 2 squared plus y minus 2 squared. Now then you would take the square root for the distance formula, and you'd want to minimize that thing. Except, well, if I'm going to minimize the square root of something, I might as well just minimize the thing squared. So, so I'll actually get rid of that, and what I want to do is minimize that. Well, except y, I need to put in my x squared plus 1. So I've got x minus 2 squared plus x squared plus 1 minus 2 quantity squared. So that's what I want to minimize. So I'll call that, if I call this f of x, I don't know, I'll call that g of x or something. And so I would take its derivative. Now, at this point with a word problem like this, I am fine with you using technology to get derivatives and so forth. So here, what we know we need to do is find g prime of x equals 0, and then we need to find that x value and the y value. And so say I'm going to use Desmos to help me. What I could do is come in here to Desmos. Now here I call it f of x, but well, let's see if I can grab that, and yeah, I can. So there I put it in. I put the y in first and then the x, but there's my function, and actually, if I'm on my function, I could go right there and tell you, oh, it's 1.165 and 0.825. Okay, so I know the answer. But we want to use calculus. We need to show we understand calculus. So what could you do with Desmos? Well, I need to set the derivative equal to 0, and so hopefully I can do that. And here's my derivative function, and so I would be okay in your write-up for this problem if you showed me a picture like this. Okay, so if I have this picture and I see that you took the, here's the function you were minimizing, here's the derivative, it equals 0. At that point you're showing me that you got 0. Great picture. And so then you could come back and say here, whoops, I don't know what I just did, try that again. Here you could say so x equals 1 point, now I don't remember what it was, 1.165, something like that, using Desmos. And again, you could include the picture. And I'm fine with that in this case, because the point is we want to know theoretically what do we need to do. So we found our critical number this way. Now I didn't actually add those things to this, but now, here's the picture, and yes, I can see it's a minimum. But again, what's our calculus say? Well, I'll put it down here. our calculus would say, well, I need to look a little bit on each side of it, right? Because that was the only critical number. And so I'll have to type it in here. Should have had it done. F and prime of, and now we're at I think we're at 1.165, so I'll do 1. So F prime at 1. And so there I could tell you F prime at 1 is negative. I could also, go in here and backspace and do 2 and tell you that's positive. So now I could, come over here and toss that in, G prime, I had a G prime of 1 is equal to negative, what was it, negative 2, something like that. G prime of 2 is equal to 24. So here you've got decreasing, increasing, and so now I know that is indeed a minimum at x equal 1.165, and then and again this is using Desmos. Now there's no picture needed here. You plug it in for Desmos and you got these numbers. And so let's go back to get rid of that. Let's go back. Why doesn't that move? I don't know. Now it moved. That's weird. Okay, so again, yes, I had it right, 1.165, and then I can evaluate it with F. Now actually, whoops, that's not the intersection. I mean that's the intersection, not what I wanted. So that is evaluating it there at 1.165, but you could always toss in a F of here, actually do your F of 1.165 to get that 0.825. And then you come back and, and so there's your answer. So you've done the calculus. You took the derivative, you set it equal to 0, you got your critical number, you checked your critical number using the derivative, using, that first derivative test. You saw the function was decreasing on the left and increasing on the right, and great, so you got it that way. Now another way you could go is you could go with Sage Cell, put the function in here and take the derivative, in which case you get this 4x squared and so forth. Now I put that into Desmos, and you see it ends up landing right on top of the old F prime, and now in green. And so I could go here and once again find that 1.165. Now how would I handle that back here? So here I said G prime equals 0. Well, I could do G prime of x is equal to whatever the heck it was, 4 times x squared plus 1 minus 1, I suppose, probably. Oops, minus 1. And then it was like plus 2x and then minus 1 or something like that. Again, don't wreck a good story with facts as far as just the process. So, by Sage Cell. Okay, so there's my derivative by Sage Cell. I set it equal to 0, and then maybe now I go plot it on Desmos, and by Desmos I get that, and and so on. Okay, so you can, on a couple of the word problems, you can go ahead and use the either Desmos or SageCell or both to help you out in calculations. But what you want to point out is that you know the calculus. You get the idea of setting derivatives equal to 0, finding things that way, finding x that way, that you know you need to check the derivative for increasing and decreasing on each side of your critical number to decide whether you have a minimum or a maximum. Okay, so you would need to add those things in, but you are more than welcome to use Desmos and SageCell to compute things and to check them. But you just need to tell me that's how you got it. You didn't phone a friend, that kind of thing. And you need to have some evidence that you could get it that way. And like I say, for the derivative, I really think you probably ought to show the picture in Desmos. In SageCell, well, you've written down the derivative, so that's fine. I think that probably does it. So that is a word problem using the technology to do some calculation.